Welcome to lesson 7.5, apply the tangent ratio. So the tangent ratio is one of many different trigonomic ratios. And trigonomic ratios simply are ratios of lengths of two sides in a right triangle. So what you want to keep in mind is anytime that you see that word trigonometry or trigonometric, then what you want to realize is that is always related to right triangles. So the tangent ratio, basically what you will want to keep in mind for today is the idea of opposite over adjacent. So if we had a triangle ABC and it was a right triangle with the acute angle A, so our angle A right here, the tangent of A, written as tan A, is defined as follows. So the tangent of angle A is the length of the leg opposite angle A over the length of the leg adjacent to angle A. So what you'll notice in the tangent ratio is we do not use the hypotenuse. We don't worry, but we utilize the leg opposite and the leg adjacent. Adjacent meaning the one that makes part of angle A or whichever angle we're looking at. Opposite would be the side directly across from the angle. So in this case, our example, the tangent of A being opposite over adjacent would simply be side BC over side AC. So how we utilize the tangent ratio, they would like us to find tangent of S and the tangent of R. Write each answer as a fraction and as a decimal rounded to 4 places. So the tangent of angle S would be the side opposite, 80, over the side adjacent, 18. Again, we do not use the hypotenuse at all for a tangent ratio. So 80 over 18 simplifies to 40 over 9, which is approximately 4.4444 if we were rounding it to 4 places. The tangent of R is equal to our side opposite, which would be 18 over our side adjacent of 80, which simplifies to 9 over 40, which as a decimal is 0.2250. So looking at example 2, find the tangent of J and the tangent of K. Round to 4 decimal places. So the tangent of J, opposite over adjacent, 24 over 32, simplifies to 0.7500. The tangent of K, opposite 32 over adjacent of 24, is approximately 1.3333. And in example 2 here, we have the tangent of J. So our side opposite is 8, our side adjacent is 15, which is 0.5333. And our tangent of K, opposite 15 over adjacent of 8, giving us 1.8750. Now, the other way that tangent is typically applied is in algebra. And when you move on to algebra 2, you will see a lot of these trigonomic ratios, especially if you go into higher levels such as some of your calculus or pre-calculus. So in this case, how we find the value of x, we set it up with the information that we were given. We knew 32 degrees, So the tangent of 32 degrees would be opposite side of 11 over adjacent side of x. Then we need to solve for x. So our first step would be to get rid of the x on bottom. So we multiply both sides by x, giving us x times the tangent of 32 equals 11. Then to solve for x, we need to divide by that tangent of 32. So x would equal 11 over the tangent of 32. Now, this is where if you have a scientific calculator, or if you don't have yours at home, Google scientific calculator and you get a free one. You can do 11 divided by the tangent of 32, which gives us x is approximately 17.6. Example 4, find the height of the lamppost to the nearest inch. So in this case, we have the tangent of 70 degrees would equal our opposite, which is our height of h, over our adjacent of 40. So our setup then to solve for h, we have to multiply each side by 40. So 40 times the tangent of 70 will give us h. So h is approximately 109.9 inches. Or if we were to round to the nearest inch, that would be 110 inches. Example 5, use a special right triangle to find the tangent of a 60-degree angle. So in this case, we can basically pick any of our side measurements for a 30, 60, 90 triangle. The easiest setup to think about is just replacing x with 1. So in this case, if we had our shorter leg of normally x, now we can call that a length of 1. Our longer leg is x times the square root of 3, so 1 times the square root of 3 is just the square root of 3. We do not care about the hypotenuse for tangent. So the tangent of 60 degrees is the square root of 3 over 1, which simply is the square root of 3, or approximately 1.7321. So any 60 degree angle in a right triangle, the tangent of that is always the square root of 3. And example 6, find the value of x round to the nearest tenth. So looking at number 3 here, we have the tangent of 61 degrees equals 22 over x. So to solve for x, we would have 22 divided by the tangent of 61, giving us approximately 12.2. Then on the other one, example 4, we were given our 56 degrees. So opposite over adjacent, tangent of 56 equals x over 13. So to solve for x, multiply both sides by 13, and x is approximately 19.3.